Hello everybody. We are now on the notes titled Proving Trigonometric Identities, and in this lesson we're actually going to be doing a lot of similar things to what we were doing in the past too. So when you prove a trigonometric identity, it's the same as simplifying. Okay? What you see down here is it says work with the side that looks more complicated. What we're actually going to be doing here is, if you look at this first equation here, what we have is something cosecant theta times cosine squared theta plus sine theta, so a complicated side, equals cosecant theta. The way that this works is we are just going to be simplifying this side of the equation, and it tells us that the answer should be cosecant. And the process of simplifying this side is actually going to be proving this identity. So it's no different than what we did before, except for we need to show our steps, and we need to make sure that we get cosecant of theta as our answer. So let's just jump right in here, and let's figure out how we're going to do this. So if we look at our first side, what we want to do is start simplifying the left side of this thing. So if I'm looking at this, I have cosecant, cosine squared, and sine theta. Now, the first thing that I can look at is, can I turn things into sine and cosine to make this a little bit simpler? So if I look at this first one, I have cosecant. Well, we know cosecant on the side over here is 1 over sine of theta. So if we change that to say 1 over sine theta times cos squared theta plus sine theta. Now notice, I'm not doing anything with cosecant. That's going to be my answer. So once I get to the end, I can show that they're equal. To multiply these, this is a lot like the one that was on your problem set as well. The top, you have cosine squared theta over sine theta plus sine theta. Now if I have a fraction, what you want to do is create a common denominator. So to make the common denominator, we have sine theta, so we need to put a sine theta here, and we need to put a sine theta there. So what we have is a fraction that says cosine squared theta plus sine squared theta all over sine theta. Now hopefully what you recognize here is that the top of this is one of our trigonometric identities. Cosine squared theta plus sine squared theta equals 1. So I can change this to say 1 over sine theta, which is equal to 1 over sine theta, we said in the beginning, was cosecant theta. Notice what we got here. When we simplified this, we got that. So proving trigonometric identities is no different than just simplifying, except for actually you're given the answer. Now, in example 1, the more complicated side was pretty simple to see. In example 2, we actually have two sides that are pretty close to the same level of complication, I guess you could say. So on the left side, we have a fraction involving sine squared y. And on the right side, we have a subtraction between secant and cosine. And it honestly doesn't matter which one you chose. If we were in class, I would let you guys pick and kind of walk through at this point, because they're both kind of the same level of how complicated they are. For the sake of this video, let's simplify the left side. So let's simplify this side over here. So the first step is going to be, actually, you know what? Let's simplify the right side, because I feel like that's going to be a little bit more straightforward now that I think about it. So let's take this right side and let's simplify it into sine and cosine to start with. So we have 1 over cos y, and then minus cos y, and we can put that over 1. Now how do you combine two fractions? Well, you make a common denominator. Cos y on the bottom and cos y on the top. So what do we have? We have 1 minus cos squared y over cos y. We're actually almost done here. 1 minus cos squared y is, if you look at this identity down here, subtract cos squared theta from each side, you have 1 minus cos squared theta is equal to just sine squared theta. So what we have is sine squared y over cos y. And if you notice, this over here is equal to what we wanted it to equal to, just like this one was in question number 1. So the process is identical, except we need to just pick a side and make it equal to the other side. So up top, it's stated pretty clearly. To prove an identity, simplify one side of the equation until it is equal to the other side of the equation. That's it. So moving on to number 3. Now, number 3 has a very clear, more complicated side. Now let me erase just this line. Let me move this just to get that out of the way. So if you look at the right side of this equation, this is the more complicated side. So this is the one I want to simplify. And in the end, I want to get cos squared of alpha. Now again, if you don't like alpha, use x, use theta. I for some reason, I'm not a big fan of drawing the alpha. It looks like an x, but whatever, you can just write a lowercase a as well, but that's besides the point. So here we go. So what can we do with sine squared alpha times cosecant squared alpha minus sine squared alpha? Well, you might notice that there's a sine squared alpha in both terms of this, which means you can factor it out. So what I have is sine squared alpha, parentheses, and let's see what's left. We have cosecant squared alpha minus, and then there's just 1 there because we took the sine out. Hopefully you notice at this point that we have a trigonometric identity. We have this guy right there, cosecant squared x minus 1. Now going over to our identities, cosecant squared x minus 1, if I subtract 1 from both sides here, is equal to cotangent squared theta. So I can now turn this into sine squared alpha times, what was it? Cotangent squared alpha. At this stage, we're still not at cos squared alpha. So what can I do with these? I can turn them into sine and cosine and see what happens. So I have sine squared alpha times cotangent, we know, is cos over sine. So times cos squared alpha over sine squared alpha. You probably noticed the signs cancel, and all that's left is cos squared alpha, which is what we wanted in the beginning. So first 3 problems, we found a complicated side, and we simplified it down, and it equals the side, or equals what was on the other side. So let's look at the next one. Let's keep moving here. So looking at number 4. Now this one is very clearly, more complicated on the left side. This one's going to take a little bit more work, but let's look at the inside of the parentheses first. So if we're looking at this, we have 2 fractions with different denominators. So your first step might be, well, let's figure out what the common denominator is. Well, the common denominator is going to be tan x secant x. We're just looking at what's inside of that box right there. That's it. So let's combine those fractions. So with the denominator of tan x secant x, let's see, that means I have to put a secant on this side, right? So secant x times secant x is secant squared x. And then I have to put a tan x on this side. And that becomes minus tan squared x. And that's all getting multiplied by this tan x that was on the outside. Now, let's look at what we have here. Secant squared x minus tan squared x. That's an identity. If you look at this middle one over here, secant squared x minus tan squared x is just 1, right? So this turns into tan x times 1 over tan x secant x. Well, tan x over 1 cancels. So the only thing that's left in this problem is just 1 over secant x. Now, if that went a little bit quick for you, please pause, rewind, make sure you understand all the steps in this problem. Now, the last step is we want to make it cosine x. Well, we know 1 over secant x is cos x. So there's my answer. And that's what we wanted. We want to match this to that. All right? So 1 through 4 are completed. There's one more that we're going to do today. We're going up to number 5. And number 5 is actually really similar to number 3. Okay, if you look at both sides of this equation, what you'll notice is that the right side is the more complicated of the two, so that's the one that we're going to want to simplify. We also will probably notice here that cosecant squared theta is in both terms, so we could factor that out. So what we're going to do is we're going to write cosecant squared theta and then 1 minus sine squared theta. What is 1 minus sine squared theta? That's right. That's an identity. And that is this first identity, except we just need to solve it. So it says 1 minus sine squared theta. So 1 minus sine squared theta is cosine squared theta. So we have cosecant squared theta times cosine squared theta. When we get to this step, it's generally a good idea to turn everything into sine and cosine and see if stuff cancels. So cosecant squared theta is 1 over sine squared theta times cosine squared theta is just cosine squared theta over 1. Now, nothing cancels, but what happens when I write cosine squared theta over sine squared theta? What is cosine over sine? Well, we already did that. That's up here. Cosine over sine is cotangent theta. So this is equal to cotangent squared theta, which is what we wanted from the beginning. I hope this lesson went well for you. I want you guys to try examples 2, 4, and 6 in the homework. So try number 2, 4, and 6 in the homework. Use the answer key I provided you to check your work. And yeah, I'll be back tomorrow with another video. Bye-bye.